Okay, smarty pants, answer this one. Do you know what earthquake magnitudes actually feel like? Well, at magnitude 1, you wouldn't notice a thing. At 3, you might slosh your coffee if you're drinking. At 5, things can start to shake off shelves, and it definitely gets your heart racing. But at 7.5, that's when the ground itself rips, buildings sway, and whole streets can split. And now, scientists warn a fault we thought wasn't active anymore could unleash something that strong under a small sleepy town in Canada. Now, if you trace your finger across a map of northwestern Canada, you'll find Dawson City in the Yukon. It looks like a nice place to escape from civilization. After all, it only has about 1,600 residents. It's quiet, remote, and famous for its gold rush past. In the late 1890s, Dawson City ballooned into a boomtown almost overnight as prospectors chased gold. Today, the rush is long gone, but the town still looks the part. Wooden boardwalks and saloon-style facades give it the feel of a set straight out of a Western movie. Oh, and beneath all of that is a fracture in the earth itself. Dawson City is located on top of what's known as the Tintina Fault. It's a massive crack in the Earth's crust that stretches for hundreds of miles toward Alaska. Until recently, scientists believed that this zone had been inactive for over 40 million years. But newer studies tell a different story. Just a quick reminder, faults are giant cracks when two slabs of Earth's crust meet. They're always trying to slide past each other, but their jagged edges catch and lock. Pressure builds for decades, continuously bending and straining the rock. Then, suddenly, the locked zone breaks, and the slabs slip into a new position in just seconds. That abrupt lurch releases all the stored energy, sending seismic waves racing outward. The ground-shaking consequence is called an earthquake. Scientists say the ground on each side of Tintina has been trying to slide past itself for ages, but it's stuck. And now, that stuck zone has built up around 20 feet of strain. That's how far the land would shift sideways if it all gave at once. That's not just a small crack. That's straight up something from a disaster movie. If all that built-up tension snaps in one go, the result could be a magnitude 7.5 earthquake. How strong is that? Well, pretty strong. So, what happens during a big quake? The shaking can last up to 30 seconds or more, which is an eternity when the walls are swaying and the floor feels like it's rolling under your feet. If you're near the fault, things can get really scary. The ground doesn't just shake, it could take a big step sideways. This can lead to some renovations. Roads might get a new zigzag pattern, and unreinforced buildings could decide to do the twist. And if it happens in a Canadian winter, let's just say it could turn a simple power outage into a survival horror adventure. Being on soft soil is like sitting on wobbly jelly. It amplifies the shaking. Solid rock is a bit more stable. However, it's still dangerous. For example, in Mexico in 2003, a 7.5 quake damaged over 43,000 homes, buckled roads, and cut power for miles. In Sulawesi in 2018, the same magnitude not only leveled buildings, but triggered a tsunami and liquefaction. The whole neighborhood was swallowed as the ground turned to quicksand. Now here's something interesting. Most people don't think of Canada as an earthquake country, but it actually gets around 5,000 quakes a year. However, they're so small that you'd never feel them. The real hot spot is the West Coast, near British Columbia. That's where you hear people whisper about the infamous Big One. It refers to a future megathrust earthquake along the Cascadia subduction zone, a massive fault that runs for 600 miles just offshore. Unlike Tintina's sideways slip, Cascadia works by one tectonic plate shoving under another. For centuries, the North American plate has been bent upward like a spring as the Juan de Fuca plate has been diving below. When it finally snaps, that's a magnitude 9.0, more than 30 times stronger than a 7.5. We know it can happen because it already has. The last big one struck in 1700. It was so powerful, it didn't just shake the Pacific Northwest. It launched a tsunami across the ocean that smacked Japan, where villagers recorded an orphan wave with no local quake to explain it. Only later did scientists connect the dots. Now this brings us to the fact that despite all this, the size of the fault, the quiet buildup of strain, and the potential for a magnitude 7.5 earthquake, the Tintina Fault isn't even listed on Canada's official seismic hazard map, at least for now. That means no warnings, no color-coded danger zones. And when a fault isn't on the map, nobody designs a building for it. There's no proper preparation. You don't build reinforced structures or have seismic codes, especially when people don't expect that the ground could split open. Now, to be honest, that's not someone's mistake. The fault just didn't show any signs of being active recently. And this part of Canada is really big, quiet, and doesn't have a lot of monitoring. Not until too long ago, people had thought of the Tintina as just a geological oddity, something cool for looking at the past, but not really relevant for the future. For years, the Tintina Fault flew under the radar, but that changed when researchers brought high-tech gear. They uncovered subtle but clear land shifts near Dawson City. They looked like scars on the landscape and pointed to past earthquakes, including one that pushed the land nearly 3,000 feet over millions of years. Now, interestingly, newer glacial features showed no signs of disruption, which means the last major quake probably happened right before the end of the last ice age. In geologic terms, that's pretty recent. When scientists lined up those land shifts with the ages of glaciers, the picture was clear. The Tintina Fault isn't retired. It's just been on a really long coffee break, and now it's itching to clock back in. That's why researchers want it officially on Canada's seismic hazard map. Dawson City deserves more than a shrug emoji when the ground decides to stretch. The experts are basically playing detective with dirt. They're scanning forests and rivers for faint scars that past earthquakes tried to hide. They're digging trenches like archaeologists with a taste for chaos, flipping through the Earth's diary one muddy page at a time. Every crack, wrinkle, and layer adds to the story of when Tintina last threw a tantrum and how loud the next one could be. It's pretty cool that satellites can literally track if one side of a valley is slowly creeping ahead of the other, like tectonic snail racing. The goal is to find out how often this fault snapped in the past, how much stress it's still holding on to today, and whether it's going to go off quietly or all at once. Finally, just because you know that plates are pushing against each other underneath, you still can't put a date on it. Long stretches of silence might mean the rocks are getting ready for something huge, or they could just be releasing stress in tiny ways that go unnoticed. Scientists can model possibilities, but no one has a countdown clock for the next rupture. The smartest mindset isn't prediction, it's preparation. You brace for the plausible, not the precise, because the Earth's schedule doesn't come with reminders. It turns out the Earth's crust is always fidgeting. It's just that our maps are a little behind on the gossip. A fault everyone thought was harmless might actually be sitting on a magnitude 7.5 size secret. But don't worry, this isn't a cue to panic. It's a cue to get smart. Better data, sturdier buildings, and a few just-in-case habits. When the ground finally decides to settle its debt, what really matters isn't whether Dawson City feels the shake. It's whether everyone's prepared enough to turn a potential disaster into just a real wild story to tell later. Hey, have you ever been in an earthquake? I have. Tell me your story in the comments.
Canada is massive, but almost everyone lives in the east or the west. And right in the middle, there is this huge stretch of land where hardly anyone calls home – Northern Ontario. So why does this place almost feel off-limits? Northern Ontario is part of, well, Ontario. It's a super busy province, home to major cities like Toronto and Ottawa. About 1/3 of all Canadians live there, but most of them are down in the southern part of the province, not up north. But that doesn't really add up when you think about it because the northern part is way, way bigger. We're talking about a region that is more than 300,000 square miles, pretty much the same size as the whole country of Turkey. Northern Ontario takes up about 87% of the entire province. But, strangely, only about 6% of Ontario's population lives in this area. But before you start dreaming about moving there for some peace and quiet, hold on. There are 4 big reasons people choose not to, and honestly, you'll probably agree. Reason number 1. The land itself. Look up the region on Google Earth, and all you will see is a huge stretch of empty space. Nothing special at first glance, but zoom in, and that's when things start getting complicated. Northern Ontario is famous for its rugged, remote landscapes, full of endless forests and lakes. It's beautiful to look at or snap a photo of, but living there is a whole different story. The geography makes the area tough to get around and makes it hard to build things like transportation routes and railways. And since it's so difficult to put decent roads up there, the whole region stays pretty isolated. That takes us to reason number 2, remoteness. You might think that, being in the center of the country, it could serve as a great link between the eastern and western parts of Canada. But in reality, that's not how it works, and the region is very far from Canada's major cities. Take Greater Sudbury, the largest city in Northern Ontario, with around 160,000 people. The closest major city is Toronto, which is about 230 miles away. So yeah, that's roughly a 4-hour drive just to get there. If you're planning a holiday weekend in a big, dynamic city, a 4-hour drive sounds like a fun road trip. But if you need to go for a dental appointment or sort out paperwork, that distance suddenly feels endless, not to mention the cost. Unfortunately, that's how life is for many people up there. Residents of Northern Ontario don't have easy access to opportunities or services. With so few people scattered across such a huge area, the region doesn't have enough facilities, infrastructure, or easy access to essential services like healthcare and education. People there sometimes have to deal with poor or even non-existent infrastructure, like missing roads, airports, hospitals, and schools. Without those things, settling down is really tough. And in rural areas, it's even worse, because the lack of services can seriously hurt their quality of life. Psychologically speaking, that's not great either. People can end up feeling isolated and lonely, and the freezing weather doesn't help. Which brings us to reason number 3 why most people don't live in Northern Ontario: the harsh climate. If you're not a fan of cold weather, you should definitely leave this region off your travel bucket list. Winters up there can be long and brutal, with temperatures sometimes dropping as low as 40 degrees below 0 Fahrenheit. Have you ever tried shoveling snow when it's this cold? Yeah, it's not exactly fun. That kind of harsh weather doesn't just mess up your weekend plans or your daily jog. It also makes transportation a huge challenge. The result is that many residents end up isolated from essential services and job opportunities. And it's also really hard to build infrastructure, grow industries, or run businesses because of that harsh climate. Take farming, for example. Compared to Southern Ontario, the northern region has a shorter growing season and much colder weather. Although crops like oats, potatoes, and green beans can handle the cold, the climate usually limits the variety of things that can be grown. That's why most farms are concentrated in the southern part of the province, and in other parts of the country, like the prairies and Quebec. Anyway, that's just one example of how the climate makes it tough for people to build a strong foundation to support themselves. And that's exactly the 4th reason why Northern Ontario is so empty: the economy. It's not that there aren't any jobs available. In fact, there are plenty. In 2023, the northern part of Ontario had some of the highest job vacancy rates in the country. So unlike in many parts of the world, it's a place where they have tons of jobs available, but no people to fill them. One reason people don't take those jobs is that many of them are older. Just look at Elliott Lake, for example. 42% of the people living in the city are over 65 years old. That's the 3rd highest concentration of older adults anywhere in Canada. But it's not all that different in the rest of the region either. Estimates show that by 2036, people aged 65 and older will make up almost 30% of Northern Ontario's total population. And you see what happens when they hit 65, right? They've got their pensions, and going back to work just isn't on the radar. This problem only gets worse because young people just don't seem interested in living there. Every year, lots of students around 17 or 18 years old pack their bags and either drive across the province or fly across the country to study somewhere away from their northern homes. And many of them don't come back. But that's actually pretty strange considering the region does have a strong economy, especially in mining. Take the Red Lake area, for example. It's packed with gold. In fact, it's home to one of the richest gold deposits in the world and has already turned out over 30 million ounces of the metal. That's definitely helped Canada stay ranked among the top 5 gold-producing countries in the world. Then, there's this region, known as the Ring of Fire. It's centered around McFaulds Lake in the Kenora district and covers about 1,900 square miles. It's rich in valuable minerals like chromite, cobalt, nickel, copper, and platinum. These days, Northern Ontario's mining industry is making a big comeback and attracting new investments. That's happening because the world is suddenly desperately looking for critical minerals. By that, I mean essential elements used in modern technologies like smartphones and renewable energy systems. Minerals like cobalt, nickel, and copper are especially important for making the batteries that power electric cars, for example. So, right now, it seems like the whole mining scene in the region is doing pretty well. But the industry has gone through plenty of ups and downs, with fluctuations and periods of decline. And that, combined with the possible lack of variety and jobs outside the mining industry, means people are more likely to leave the region in search of better opportunities. Interestingly though, mining companies are now struggling to find enough skilled workers in Northern Ontario. And that's probably because of all the reasons we've already talked about: an older population, harsh weather, tough geography, and a long distance from major urban centers. So, it's basically a cycle. And local authorities are trying to break out of it by improving infrastructure in the region, offering more incentives, and finding ways to keep young workers from leaving. Some of their strategies include offering cash rewards to people who refer healthcare workers for job openings or providing tax-free payments to help cover higher home energy costs. And there are plenty of other initiatives too. So yeah, with strategies like these, it's definitely possible to grow the population there. And who knows, maybe one day this region could be bustling with people. Some places don't look important until the world realizes they hold the keys to the future. That's the case with Canada's Arctic. For most of history, it was just ice, snow, rocks, caribou, and even more ice. But now, it's about to become one of the most important places on Earth, and maybe make Canada a global superpower. Why? Because it's hiding minerals that power electric vehicles, satellites, and missile systems, while the demand is skyrocketing. However, it's not just mining and having resources, it's also about control. Right now, China has a massive head start because it refines over 90% of the world's rare earths. That means if you want to launch a satellite, manufacture advanced electronics, or even just keep the lights on in your fancy smart home, odds are you're relying on China. And that makes a lot of world powers very nervous. Because when everything's going electric, the last thing you need is being dependent on your geopolitical rival. So now, the global clean tech treasure hunt is officially on. The US, Europe, Japan, Australia, they're all competing. However, the latest technology and untapped potential might give Canada the upper hand. Canada's had these minerals for decades. But with low prices, tough terrain, and no global rush, they mostly stayed untouched. However, Ottawa is finally stepping up its game. Back in 2022, Canada rolled out the Critical Minerals Strategy with billions in funding and tax perks to get companies digging. There's also plans to build the necessary roads, ports, and power lines to tap into those remote deposits up north. Canada already produces more than 60 minerals and metals, but 31 of them are now considered critical. 6 of those are having VIP treatment: lithium, graphite, nickel, cobalt, copper, and rare earth elements. But digging it up is just step 1. The real plan? Keep it local. Melt that frozen treasure into shiny new batteries right at home. That means not just mines, but also refineries, processing centers, and high-tech factories popping up where there used to be nothing but snowdrifts and silence. While others are talking, Canada's busy paving roads and stringing power lines. Slowly but surely, they're turning snowfields into a high-tech playground. Getting to all that buried treasure used to be nearly impossible. After all, we're talking about land so remote that roads literally stop hundreds of miles too early. The ground is frozen solid for most of the year. And even if you found something valuable, just getting out was a logistical nightmare. So what changed? Canada has an ace up its sleeve. Don't know about you, but I use it mainly for making memes and music. But geologists? They're scanning the Arctic like it's Minecraft with X-ray vision. Instead of drilling blind, they're using decades-old core samples, plugging them into AI and getting shockingly accurate predictions about what's underground. It's like upgrading from a pirate's treasure map to a GPS that actually says, "Dig here." Companies like Geologic AI and Cobalt Metals are already doing this, pouring data into AI and getting X marks the spot hits for nickel, cobalt, and rare earths. In the Northwest Territories, Canada is running a pilot lab that uses AI and digital scanning to reanalyze decades-old rock samples. The goal is to spot hidden mineral deposits that old methods might have missed without digging a single new hole. All that sounds great, but maybe I made it sound simpler than it is. Digging up the Arctic is a logistical nightmare. For starters, this isn't just a remote patch of land. The Canadian Arctic is huge. Almost half the country, stretching over Yukon, the Northwest Territories, and Nunavut. We're talking about a region larger than India, with fewer people than a small city. Most of it is permafrost, wilderness, or ice-covered islands scattered across the Arctic archipelago. Temperatures go from barely 50 degrees Fahrenheit during summer to negative 40 degrees Fahrenheit or colder, with ground that stays frozen for most of the year. Fun fact, did you know that negative 40 degrees happens to be the same as negative 40 degrees Celsius? It's the one temperature where both scales intersect. They climb at different rates, but eventually cross paths when it gets cold enough. Just a small trivia nugget for weather nerds like me. Anyways, you can't just roll in a truck and break ground in the Arctic. Up there, roads just stop. Want to build something? It can take years, and one nasty winter can put everything on ice. And if you want to continue up north, you need more of everything. More food, more fuel, more machines, which means even more money. Speaking of money, another chilling fact is how much this all costs. Mining in the far north is way more expensive than doing it in, say, Australia or Chile. An AI might tell you where the minerals are, but people and big machines still have to dig, and that costs a fortune. But that's not all. Most of the Canadian North is Indigenous land. First Nations, Inuit, and Métis communities have lived there for thousands of years, and mineral hotspots often sit right on their ancestral grounds. So when Canada talks about unlocking the Arctic, it's not just a question of roads and robots. It's a question of partnership and collaboration. And that's not optional. Legally, projects on Indigenous land require consultation and, in many cases, consent. The good news, some communities aren't just involved, they're leading the way. In regions like Nunavut and the Northwest Territories, Indigenous-owned corporations and world powers are already shaping how development happens on their terms. If Canada wants to pull this off, it's going to need more than tech and funding. It's going to need trust. So with all that in mind, can Canada pull this off? Honestly? With technological advancements and partnerships, it doesn't seem impossible. But Canada isn't just doing one thing right. It's doing a bunch of things at the same time. Let's recap. Hidden resources? Checked. New strategy? In place. Big funding? Approved. AI tools? Deployed. Indigenous partnerships? Underway. Infrastructure? Already breaking ground. It's a snowball turning into an avalanche. Exploration boosts investment. Investment speeds up roads. Roads unlock more deposits. More deposits attract more factories. It's a feedback loop. And if they keep feeding it, the whole Arctic operation could go from an idea to empire faster than anyone expects, giving a whole new meaning to the phrase frozen assets. But this doesn't just help Canada. It could save the US a whole lot of trouble. If all goes to plan, the US won't need to ship rare earths halfway across the planet. It can just look north, wave at the caribou, and get what it needs from its closest neighbor. That's why the US has publicly backed the effort, offering support and funding to help build a trusted North American supply chain. For Canada, this could be the moment it stops being just a supplier of raw materials and starts becoming a critical power broker in the clean tech economy. For the US, it's like discovering your neighbor has been secretly building a battery factory in their backyard while you were building electric vehicles. And globally? Well, the abundance of resources tends to lower the prices, and that's always a good thing for us regular people. Cheaper cobalt, nickel, and lithium mean cheaper batteries. And cheaper batteries mean more affordable electric vehicles, energy storage, phones, laptops, the works. Now, don't get too excited just yet. Like we said, mining in the Arctic isn't cheap. But in theory, once Canada's clean tech engine is fully up and humming, more supply and shorter supply chains should gradually bring costs down. And it's not just about price tags, it's about stability. Right now, if one country cuts exports or gets caught in politics, everything down the line gets shaky. But with Canada stepping in as a reliable supplier, the global system might get a bit more breathing room. Manufacturers can stop sweating over single points of failure and start building with confidence.
Hey, quick question. How many continents are there? 7? Maybe 5? There's no correct answer. According to different approaches, the range is between 4 to 7. But it might actually be as many as 8. Chances are, a lost continent has recently been found between Greenland and Canada. This new continent discovery could also potentially be the key to how microcontinents form. What does this all mean, and what makes this hidden landmass near Greenland so important? Now, if you're like me, and if you are, then there's 2 of us, when you hear the word continent, you probably think of land like Europe or Africa, places above water where people live. But in science, a continent isn't about being above sea level. It's about what the land is made of. Earth's outer layer, called the crust, comes in 2 main types, continental and oceanic. Continental one is thicker, lighter, and made of different types of rock, like granite. The oceanic crust is thinner, heavier, and made mostly of dark volcanic rock. Now, the discovery under the Davis Strait between Greenland and Canada appears to be a piece of continental landmass, even though it's under the ocean. Scientists call it a proto-microcontinent because it began to break off from a larger terrain millions of years ago, but never quite made it. As tectonic plates slowly shifted, the Earth's crust in this region stretched and cracked. One chunk started to split away, but for some reason, the process stopped. It didn't drift off like a full continent, and it didn't sink like ocean crust either. Instead, it stayed right there, floating beneath the waves all this time. This makes it different from true microcontinents, like Zealandia, which have completely detached and now exist as separate tectonic blocks. Zealandia is a submerged microcontinent near New Zealand. About 94% of it lies underwater, but because it's made of continental crust, many geologists say it qualifies as Earth's 8th continent. However, Zealandia is still debated because it's too big to be a microcontinent, and there's no official global body to define its status. There's no global organization like the UN or some kind of international geology council that can declare, hey, this is a new continent. Unlike Madagascar, which is fully above sea level and widely accepted by geologists as a classic example of a microcontinent, Zealandia is still waiting for a proper label. I know you're probably wondering, isn't Madagascar an island? The simple answer is, it's both. It's the 4th largest island in the world, completely surrounded by water. But it's also geologically considered a microcontinent because it broke off from the supercontinent Gondwana around 88 million years ago and is made of continental crust, not oceanic crust. Unlike volcanic islands like Hawaii, this isn't just built from lava. It's a real piece of ancient continental crust. So Madagascar checks both boxes: island by geography, microcontinent by geology. And that's exactly why these discoveries can be fascinating. Just like Madagascar stands out above the waves, this newly discovered landmass under the Davis Strait stands out beneath them, thanks to its unusual structure. What makes it stand out is its unusual thickness. Most of the ocean floor is thin, like metal. This is more like packed clay, layered with continental materials. Underneath this cozy comforter, scientists discovered some odd layers of rock, unusual because they're not where they should be. These layers act more like the materials found on continents rather than those typically seen on ocean floors. There are hints of granite-like formations and distinct magnetic properties, which suggest that this stuff is similar to what makes up dry land. The size is also remarkable. The proto-microcontinent is about 12 to 15 miles across, which makes it roughly the size of a mid-sized city, like Manhattan Island at 6,500 feet underwater. The fact that it sits right under the Davis Strait, one of the widest ocean passages on Earth, makes it one of the largest submerged continental fragments we've found. According to researchers, this landmass began to form between 58 and 49 million years ago, when Greenland and Canada were slowly drifting apart. Maybe they just weren't getting along. Hey, it happens. As they pulled apart, the crust under the Davis Strait stretched, and one of the main fault lines shifted. But the breakup didn't finish. Around 48 million years ago, the rifting stalled and Greenland's motion away from Canada slowed dramatically when it later bumped into Ellesmere Island. It's like a car swerving off and then back onto the freeway, a turn that was never completed. That's basically what happened. A chunk of land got stuck between the motion. It didn't float off into the ocean like a new continent, and it didn't get pulled down into the Earth either. It just stayed where it was, stranded beneath the water. But that's not all. This chunk has its own fault system, and scientists say it actually looks like a miniature version of the San Andreas Fault in California. Now, a fault is basically a crack in the Earth's crust where sections of rock slide past each other. Think of it as a place where the Earth's surface split and tried to slide sideways. In California, this movement still happens today and can cause earthquakes. But under the Davis Strait, it's a different story. The movement started, then suddenly stopped, like hitting pause in the middle of a big shift. It's a frozen moment in the planet's past, preserved right beneath the waves. For geologists, that makes the microcontinent under Davis Strait incredibly valuable. That sudden pause in motion helps explain why some chunks of land break away cleanly, while others twist, stall, or disappear. But this isn't just academic. By studying how continents break apart or stall, scientists can better predict future shifts in land, fault lines, and seismic activity. And predicting earthquakes and geological hazards could prove quite valuable to everyone. Knowing how microcontinents form could help us anticipate how the planet's surface might shift over millions of years, which affects everything from climate models to resource availability. But even just the technological advancement needed for such discoveries is greatly beneficial. The same tools used to map this hidden land are used for oil exploration, laying undersea cables, climate monitoring, and even search and rescue missions. Speaking of technology, for a long time, this hidden landmass near Greenland remained invisible. Just 10 or 15 years ago, the ocean floor under the Davis Strait was basically a mystery. It's deep, almost frozen, obviously not the easiest place to explore. But today, thanks to modern tools, a new continent discovery could be just a matter of time. Scientists can finally see and hear what's going on under all that water. First, they use seismic reflection imaging. That's a method where ships send sound waves down to the ocean floor and record how they bounce back. Various layers of rock reflect sounds in different ways, which helps build a picture of what's hidden underneath. It's kind of like how bats use echoes to see in the dark. Satellites also play a role in collecting gravity data. This may sound strange, but different types of rocks have slightly different weights. Heavier rocks create stronger gravitational pull, and satellites can measure those tiny differences. Another tool commonly used for these explorations is underwater sensors, which sit quietly on the seafloor and listen for natural vibrations, like mini earthquakes or shifts in rock. These vibrations help scientists figure out what the crust is made of and how thick it is. They're basically ears on the ocean floor. They also most likely used AUVs, or autonomous underwater vehicles, basically robot submarines that can scan the seafloor in high resolution even under thick ice. In any case, scientists are very excited because this new continent discovery is more than just a geological surprise. It's what they call a natural laboratory. The study of the microcontinent Davis Strait offers a rare opportunity to understand how microcontinents form, evolve, and sometimes fail to fully separate. It also reminds us that Earth's crust isn't as neatly divided as we once thought. Beneath the ocean, there may be other hidden landmasses near Greenland or elsewhere, almost continents, just waiting to be found. This lost continent of Canada may not have made it as a fully fledged landmass, but its discovery is already reshaping how we view plate tectonics. And thanks to advances in technology, places we once ignored are now offering up secrets about the planet's deep past, and maybe even its future.
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the 5th largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the 5th largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground, but there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of 3 main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
A 4-story wall of water that only rises once in 1,300 years was recorded off the west coast of Canada. Some people blame waves like this for disappearances in the Bermuda Triangle. Rogue waves can get strong enough to sink container ships and oil rigs. The Canadian water monster didn't hurt anyone, but it did become a sensation. And it looks like we're about to see even higher and more powerful rogue waves in the future. The team of Marine Labs, the company that operates the buoy that got caught in the Yukon wave, couldn't believe the data they saw. A huge force came out of the blue, pulled the buoy down, and then set it up to a peak before taking it even deeper. They thought it must be a rogue wave, so they sent the data to a scientist at the University of Victoria who specializes in these beauties. They analyzed the data and confirmed it was indeed not a technical mistake. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Scientists have reported seeing giant waves coming out of the blue for centuries, but no one really believed them. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got in a terrible storm and saw several waves over 98 feet tall. That's almost as tall as a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and shared what they saw. But back then, scientists were sure waves couldn't be taller than 30 feet. Everyone took their story as a tall tale. Pun intentional. Over a century later, a cargo ship, the MS München, mysteriously disappeared. People believed it to be unsinkable, just like the Titanic, so it was a real shock that all that was left of it was one lifeboat. When experts analyzed the damage, they concluded that it must have been hit by a wave that was around 65 feet high. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This monster on the North Sea that was 84 feet tall hit the Norwegian gas platform Doppler on New Year's Day. It was twice larger than the wave surrounding it. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. The wave wasn't like any other type of wave they'd studied before. So they had to admit rogue waves were real and gave them an official definition. It's a wave more than twice as tall as others around it. They can pop up lightning fast in a stormy sea, or show up out of nowhere in calm waters. These waves have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters trying to do their job. In 2007, America's National Oceanic and Atmospheric Administration made a list of 50 historical maritime tragedies that were most likely caused by rogue waves. Some of the events on the list happen not in the open water, but in lakes. Lake Superior has something that's got the name Three Sisters. It is a series of 3 large waves, one after another. The second wave covers the ship's decks before the first one is gone. The third wave jumps in and adds extra water. These three sisters overload the ship. There's a theory that this phenomenon took down the freighter Edmund Fitzgerald in 1975. There are two main theories trying to explain how rogue waves happen. First, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. When these waves cross paths, they team up and become stronger to turn into a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they exchange some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and put in a math model that would create a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but there is a huge progress in this direction. Scientists from the University of Melbourne went on an expedition to Antarctica and found out that strong winds play a big role in the creation of rogue waves. It looks like they're caused by a mix of strong winds and the random way waves move and interact with each other. This idea was tested in labs before, but now they've proven it happens in real oceans too. To study these waves, the scientists use special 3D cameras. These cameras work like human eyes, taking lots of images in a row to create a detailed 3D picture of the ocean surface. It showed that rogue waves happen more often when waves are young, which means they're just starting to form and are more affected by the wind. When strong winds blow over young waves, they make the waves taller, longer, and faster, but not evenly. Some waves steal energy from nearby waves and grow much bigger, which is how rogue waves form. The scientists noticed these giant waves happened about once every 6 hours. They recorded no rogue waves in calmer seas when the wind doesn't have as much influence. Scientists are concerned that rogue waves may happen more often in the future because there's more energy in the atmosphere and ocean. It looks like rogue waves can be much more powerful than scientists ever thought. They managed to create the famous Doppler wave in a lab for the first time in 2018. This helped them study these mysterious waves up close and showed that their secret is in how they form. We think of waves rolling gently on a beach, but the waves in this study happen in open water when waves from different directions meet. When waves come together from far apart directions, they push the water upward, creating what's called a partially standing wave or a cross wave. This can happen when two seas meet, or when wind directions suddenly change, like during a hurricane. The study found that the bigger the angle between the meeting waves, the taller the cross wave becomes. Normally, when a wave breaks, it forms a white foamy top, and that's where it stops growing. But if a wave is formed by water coming from many directions, it can keep growing even after breaking. These special waves can grow to be twice as steep while breaking, which is already much bigger than normal waves. And if you add up all the growth from waves coming together, they can become 4 times steeper than what anyone thought was possible. This discovery could change the way we build things, like wind turbines or oil platforms in the ocean, to make them safe. Right now, many designs don't fully account for these huge multi-directional waves. Now, they seem to have a lot of similarities, but rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves.